All right, so in this video, we're going to be looking at how to solve an absolute value inequality. Now, in this particular case, we're looking at an absolute value inequality with a greater than sign. And what that's going to do, if you think about your absolute value graph itself, it looks like a V. And so to be greater than that, you're going to, if the V opens upward, you're going to be in two separate pieces, one on the right, one on the left. If we were dealing with a less than, we would be below the line y equals 2. And so there would be a V-shaped portion that connects. So we'd have a continuous section. So what's going to happen with our solution in this case is we're going to have two separate pieces. We're going to have one where the inside of our expression is greater than 2, where the absolute value is not applying. But we're also going to have another one where the inside is going to be less than -2, because if you have a number that is less than -2, like say -3, and then you make it positive, you get a 3, which is greater than 2. So we're going to have two separate pieces. So the positive side is going to take this expression and simply drop the absolute values. And then there's going to be a negative side, which is going to be this same expression, but it's going to be less than -2. So notice when I applied the negative sign, I also had to flip the inequality. Now, if you apply the negative sign on the other side of the equation, you don't have to flip the inequality, but then you'll have this negative sign you'll have to move over, and when you move it over, it will flip the inequality. So again, however you want to end up doing it, keep in mind the inside of your expression, greater than 2 doesn't do anything, it's on the outside, and then there's a separate piece where it's on the left side. Again, think about your V-shaped graph. And at the end, we'll draw these two and we'll look at where, in fact, the inequality applies just to check our answers. All right, so once we have our two equations separated out, we can go ahead and we can solve each one separately. So in this case, I'm going to multiply both sides by 3 to get rid of the denominator. So 2x plus 6 is going to be greater than 2 times 3, which is 6. That makes total sense because, of course, I haven't changed any signs. I haven't multiplied by any negative numbers. I don't have to change any inequalities. I'm going to subtract 6 from both sides of the equation. I'm going to get 2x is greater than 0 because 6 minus 6 is 0. This is perfectly fine. X divided by 2, 0 divided by 2 is still 0. So on the one hand, I have x greater than 0. If I do the other negative version, the process is basically the same. I'm just going to get a slightly different answer. I'm going to multiply both sides by 3. 2x plus 6 is going to be less than -6. Now I'm going to subtract 6 again, but I'm going to get 2x is less than -12 because -6 minus 6 is going to be -12. It's not canceling, like giving me 0. And then if I divide by 2, I get, again, I'm dividing by a +2, so I don't have to change the sign again. -12 divided by 2 is -6. Now, again, let's think about this on a number line so that we can write it in interval notation. So here's our number line. Now, for this one, let's put 0 on here, and we'll put -6 on here. Now, this is x greater than 0, so greater than is going to be out on this side. And we originally had no equal sign, so again, open circle or around parentheses. So again, for interval notation consistency, I'm going to use the parentheses. And then for the -6, this is x is less than -6. So it goes out here down to -infinity. And again, no equal sign, so round parentheses. So my interval expression is going to have to be in two parts, because if this was a less than problem and not a greater than problem, the two places would meet, and you would have to have both of your problems be true at the same time. In the greater than case, it's an either or case. So since our intervals don't overlap, we don't have to reduce them to a single interval because we can't. So it's either going to be x is less than 2 or x is going to be greater than 0. Again, if this was a less than, we would have them both be true at the same time. It would be an and scenario. And then we would have a single inequality with our two values on the end. Now we can go and graph this, take a picture of the original equations and see that this is in fact going to be correct. Now, if we graph go back to our original problem, our absolute value as the left side as y equals, that's one problem. For the graph, I pulled the 3 out of the absolute value because it's not being affected by changing signs. And then also graph the right side of the equation, y equals 2, and see where the absolute value is greater than 2. And so when I graph that, I get this. Here's my absolute value graph. Here's my line y equals 2. And I can see that this leg of the absolute value is going to be bigger than 2 when x is a value that is to the left of -6, so less than -6. And also it will be greater than 2 when x is a value that is greater than 0. So that's that portion of the graph. So again, in the x direction, in between -infinity and -6, and then it goes to be less than for a while, and then it pops back up. And now once you get past 0, it's going to stay greater than 2 the rest of the time.